Welcome to Team's Top Notch Academy. Today we're looking at this topic, the gradient of a straight line graph. This topic involves coordinates. Let's say you are given a coordinates x to be 0 and 3, and you're given y to be 4 and 2, and it has to solve. How do you go about this? This is the reason why I'm going to treat this topic today, and you'll be able to navigate any challenge that comes your way in terms of these coordinates. Now, how do you define the gradient of a sloping line? We define the gradient of a sloping line using this figure. Let's call this figure A, okay? Though we don't have figure B, but let's just call it figure A. We define the gradient of a sloping line as a vertical distance, okay, that rises and falls between P and Q, divided by the horizontal distance between the same P and Q. So what do I mean? We say gradient of a sloping straight line is defined as the vertical distance, okay, that rises between P and Q, okay, divided by the horizontal distance between P and Q. So that's the definition. Okay, so where P, which you are seeing here, the point P, is the point towards the left of Q, which rises and falls towards the right. Okay, so it rises and falls towards the from left to right. That's what P, the point P here is. Now, having defined the gradient of a straight line, we need to know what is this dx dy that we're seeing here. This dx dy is the changes between s and y axis. So this is y axis, okay? Let's call this y axis, and this is x axis. So the changes at s axis is known as for s, the changes at s axis is known as the x, and the changes at the change at y axis is known as the y. What do I mean? So when you are evaluating the s and that of the y, you see that the change, what I mean is the change will have a value here and also have another value here. The difference here, which is the value here minus this value, is the x. You know, when you are having a line like this, if the line starts from 0, we have 1, 2, 3, 4, and 5. So let's assume that this point falls under 1. So we assume that here falls under 4. So you know that 4 is greater than 1. So that's why we call it dx, meaning that here is x1 and here is x2. And to get the x, which is the changes, you say s2 minus x1. That's the change. Then in that of y, let's say here is y, and y is also from 0, 1, 2, 3, 4, and 5. So let's say this falls under 2, okay, and this falls under what? 5. So the changes here can now be what? Y1, here can now be what? Y2. So the changes should now be what? Y1, Y2 minus Y1, which is what? 5 minus what? 2, being what? 3. So to get the this gradient now, based on the definition, we say that the gradient of a sloping straight line represented by m is, you use m to represent this gradient. Wherever you see m, you know we're talking about gradient. Okay, so it's equals to what? Dy over what? Dx. That's the definition of gradient. Okay, dy over what? Dx, where we can also simplify it further based on the simple explanation I've given to you, to be m is equals to what? Y2 minus what? Y1, all divided by what? X2 minus what? X1. And this is how you solve your problem. With this, any question that is given to you under coordinates will be what? Solved very, very well. Okay, it's as simple as ABCD. So make sure to check other videos that I'm going to drop on this particular topic. So there are examples. I'm going to solve more examples. So as you look at the examples, you'll be able to understand it very clearly how to apply this. Okay, please make sure you stay subscribed, because that is what that will give me the energy to give you more values, creating more examples, and I believe you're going to get what you want from here. Okay, this channel is the best. Okay, thank you.